In this third demonstration, I will use a flute signal and a speech signal as examples of more complex signals to be modulated. Using a technique based on reading a wave file and extracting the left channel, which is typically the monaural channel, I'm displaying the sampling frequency and then multiplying this by my sinusoidal signal source right here. The modulation frequency FM is my front panel control. I then convert this to the waveform data type and send it to both play waveform, express VI, and the triple display. I'm using a while loop to keep cycling through. That way I don't have to keep pressing the run button. And the reason I'm using my feedback node on the phase is so that I don't have the clicking noise on each pass through the loop. Let's try the flute first. Now let me change this to 0 so we can just hear the flute by itself. Let's consider the spectrum of the flute. We see our fundamental frequency and a number of harmonics. Also, we can see the vibrato of the flute gives the kind of wiggly lines to the spectrogram. But generally, we see the harmonics are constant. And very low values of modulation frequency give the tremolo effect. Let's speed that up a bit. Alright, let's put the modulation frequency more into the audio frequency range. To 220, or listen, I should say. Now the flautist is playing 440 Hertz or concert A, so by modulating it by 220 Hertz, which is 1/2 of 440, it actually makes all the harmonics come back together, and it fuses together into what we perceive to be a single pitch again. So we do have spectral overlap showing up there. Similar things happen if we go with a multiple of 440 or even 880. So again, we see that all the spectral copies, when they are shifted by an integer multiple of our fundamental frequency, all those spectral copies have their harmonics lining up, and it sounds like a single note again. Again, when we do something different than that, then the harmonics spread far enough apart that it sounds like two distinct tones being played, or two distinct pitches. All right, let's try this with some speech.
Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch.
Alright, so that's my original source signal from the spectrogram view. Spectrum view is probably not real helpful. Time domain, you can kind of see where the two sentences are located in time, but our spectrogram view is by far the most useful to us right now.
Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch.
Now, if you look carefully, you started to notice an interesting behavior on the spectrogram. You'll notice this band, which seems to be creeping up from zero frequency. We can sort of discern that on the spectrum, but again, it's much more visible in the spectrogram. Now I'm going to select something right around 500 Hertz and watch right there.
Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch.
Now that band is our DC frequency, but yet when we apply our modulation, we're actually moving that to a higher frequency. Any components that are at the top of the spectrogram effectively wrap around to the bottom side. And that's an aliasing effect showing up. We can also think of that as the negative components are appearing into the positive side of the frequency spectrum.
Rice is often served in round bowls. The juice of lemons makes fine punch. Rice is often served in round bowls. The juice of lemons makes fine punch.
Now this is a particularly interesting one. This is with the modulation frequency, which is exactly 1/4 of the sampling frequency. You'll notice how we have caused the DC to appear right in the center, and we've got a symmetrical baseband signal showing up on either side. So again, this kind of gives you a very interesting special effect for that particular value of modulation frequency.